Problem. Saving it? You doing it?
No, I'm saving it.
Oh, okay, control. All you do is the shift, print screen.
I had to turn it on my settings.
What?
The
Shift, print screen?
screen print, I had to turn it off.
Oh. Just use the school computer. All right. Okay, class. So let's look at chapter 3. All right, chapter 3. Minimize this. All right. Well, and like I said, before we go into that, let's get into this. All right, let's look at this. All right. The 20 commands, right, or the 20 keywords. All right, most of you got all of your points. Some of you may not have. Reason being, backslash, that's not a keyword. Not equal to, that's not a keyword. Equal to, not a keyword. Double quotes, single quotes, less than, greater than. Those are not keywords. Okay, so I took off for that. All right. Some of y'all gave me paragraphs like I told you I didn't want. I didn't want that. Just a simple statement as to what that command did in that compiler. Okay. The second, the program escape. Chapter 2, escape sequences. The first program. Remember what I told you, class. I wanted the output to be like it looks in the example. Some people did it. Some people did not enclose bears and the double quotes, the percent sign, and the double quotes within double quotes, and the slash and backslash. What they printed out was slash, percent, double quote, bears, double quote, that was the first one, backslash, slash, percent, and that's it. I wanted everything that you saw here, right, in the output. Everybody understand it? And the same thing, how you doing, Miss Frasser? All right, same thing for the next one. For this one, enclose it in double quotes. Some people didn't do that. Then some people got confused with the slash and the backslash and the whatever. I don't know what you was doing, right? So I took off for that, right? Some people didn't even use escape sequence. Took off for that. How many people still have issues with the header file? Got issues with it, right? Who is Mr. Give it an R. Is this the class? What's your name? Romo, Mr. Romo, your program works in the sense that there's no errors, but you have it somewhat reversed. The logic should be in the CPP file. In the header file, you should have the name, your name, the course name, in a function that you're going to call. The project name, my name, the due date. So when you execute the CPP file, it's going to call the header file, which going to output your name, the course name, whatever, and then it's going to return back to the main program and execute the code in the CPP file. All right? Okay. All right. What's your issue, Mr. What? Yeah. It's just the header file, period. Okay, one question. Did you look at the announcements? You didn't go to announcements and look at the example header file information I gave? Huh? I gave a program that had what? A header file written within it. Right, class? So you was able to use that as an example to write your code. Does that help? Huh? It will help. Okay. Some people writing code without the header file at all, just not even trying to do it. That's 5 points off the top. So if the assignment is 10 points and I'm taking 5 points, you just made an F. If it's 25 points, I took 5 points, you got a B. When that's not minus whatever else you did wrong. I want the header file. I gave you the instructions how to do it. I went over it a couple of times how to do it. I want you to do it. The more you do it, the more comfortable you're gonna be with using using header file and understanding functions. So I gave it to you for a purpose. Right, class? All my programs that you do, I want that header file. Everybody understand that? Okay, all right. The next program, okay, some people did it somewhat. Some people, I didn't understand what you was doing. This program, I gave you two numbers, right? In inches, right? 73 and 49. You were to add those two numbers together to come up with 122, right? So you had a variable that was equal to 73, a variable that was equal to 49. Some people did CSCI. I kind of allowed it, I let it go somewhat, but I gave you the values, all right? Then I looked at the mathematical calculations, all right? Some people use the modulus, then they divide with the int and then the modulus. Cool, no problem. Some people, they have their own function, their own expression, and they come out wrong. Some people didn't even add it up together, and they did one and gave feet and inches, the other one gave feet and inches. That's not what I asked, right? That's not what I asked, right? And then my output should have been in this format. Some people, the conversion of whatever, I didn't ask for that. I asked for this. This is the sample output. The output is given. So when you see some sample, when you are working in a company and they give you a sample of the output, excuse me, and they give you a sample of the output.
I heard you call it later.
No, that's email. From one of y'all probably at school. But when they give you a sample of the output, they're telling you this is what it should look like. So when you write your code and generating your output, it should match, that output. All right? They don't give it to you for nothing. Right, class? All right. Then the next program. Here, some people did well with it. Some people, I don't know what you was doing. Remember we went over expressions, and we said that in math, the algebraic expressions, 2a is what? 2 times a. 4b is 4 times b. 3ab is 3 times a times b. 5a is 5 times a. You understand? 2b is 2 times b. What you had to do, take this expression and write it out in the C++ statement, all right, as an expression, and also give A a value, give B a value, solve that expression, and give me the result. That's all you had to do. So example, if A was 0 and B was 1, what would the answer be? Huh?
Wait, what?
If given this expression, right, we know we got to change it up to put it in the computer, right? Because that would be A 2 times A, right? But, and on and on. But if A was 0 and B was 1, what would this expression yield? What would be the result? -2, right? 2 times 0 is 0, so that's thrown out, right? 4 times 1 is what? 4, right? But that's a negative in front, but we'll leave that there. 3 times 0 times 1 is what? 0. 5 times 0 is what? 0, so we subtract 0, that's gone. 2 times 1 is what? 2. So a minus 4 plus a 2 is what? Negative 2. Everybody understand what happened? And the computer was going to do that for you. You understand? No matter what values you gave A and what values you gave B, right? It would do that and solve. All right? So that was the assignment for that program. Okay, so let's go back and let's start out with chapter 3. All right, let's go back into chapter 3. All right. Let's see if I'll get there. But we somewhat started chapter 3, and like I say, I'll kind of breeze till we get to the point where we kind of left off. So we know how to use the CN statement. What's the purpose of the CN statement, Mr. what?
Flores.
Flores. What's the purpose of the CN statement?
Read data.
From, normally, from the keyboard, right? We doing it from the keyboard at this time, right? But it's the read in the data, right? Okay. Everybody have used that statement, correct? That CN statement. Okay, well now, what normally is a rule with the CN statement? It should be accompanied by what? What statement? The who? The C out. And that the purpose of that is to what?
Display the data.
So display,
The user input.
display, huh?
The CN, not the user, the outcome.
Well, display a message to the user as to what it is he or she needs to input, right? Because what? Just to have a CN, your cursor just blinking on the computer, just waiting, and you don't know what to input. Normally, you would have a prompt that says what? Please enter a whole number. Please enter your name or whatever, right? Which guides the user as to what to type into the computer. All right. So that's the CN statement. All right. And normally, look, CN length. But what? Before length, you have what? A string that tells the user what it is that's being inputted. Because CN length, we don't know what's being inputted, correct? So we have to somewhat know. And you as a programmer, you have to keep your program organized. And he said, well, Mr. Sylvester, what you mean by that? If I have a length and a width, 2 different variables, correct? Now, the program may still give me the correct answer, but logically it's wrong. Example, if I had C out, what is the length of the rectangle? Okay? Then CN width. You got me? Then C out, what is the width of the rectangle? CN length. And then I'll say area equal length times width. I'll get the right answer, correct? But when I start using another expression and I'm using length to do something, I may what? Run into problems, right? So like I say, you as the user need to as the programmer, need to make sure what? Your CNC out aligns and properly matches what it is to be input, right? Okay, all right. Now, we talked about this, where we can input multiple variables values at one time. Simply do what? You just streaming in the first one, streaming in the second one. But at the same time, as I said, you as the programmer, you dictate to the user as to how to input that data, all right? Because what? If I'm giving this CN length and width, I would have a prompt that says what? Somewhat to the fact of what? Please enter length and width separated by a space. You understand? So I'm telling them, give me the first one, which is length, the second one, which is width. Because I can say, please enter your name and age. You understand? Where I can have CN name, stream, age, right? But then if I have them swapped, then what? Then I'm trying to pull the wrong data into the wrong variable. Everybody got that? So you got to stay logically in order. All right? So, Now, we talked about how you can have issues dealing with even chart values, but numeric values when you do not, how would I say, input the right data type variable value in for an input. Okay? Give an example. Here it says, and this program allows you to input a whole number, a fraction, and a letter. Okay? That's what this program is telling you. Int, whole, double, fractional, chart, letter. Now, they entered a 4, correct? And that went into whole. They entered 5.7, that went into the fractional. They entered B, which went into letter, right? No issues, no problems. The data that was entered for each variable was correct, all right, of the right format per se. But what happens is, if I alter this and say I'm gonna put 5.7 before I put 4, then all of a sudden I'm throwing my data off in that the first value that I'm reading in is whole. So it's gonna say what? I can only receive a what? A whole number. And it's gonna grab what? 5. You understand? And then the next one is a fractional value. It's gonna accept what? 0.7. So see already we done what? Destroyed our data. Our data is really garbage now, right? Because we don't have the true data, correct? And then it's gonna store 4 for the character value. And now B is left out there. If I have another CN, it's going into that. You got what I'm saying? So it won't allow me to input another value in my next CN statement because that B will be stuck in my buffer. All right? So you got to make sure that the data aligns with the input. And I mentioned before, as you become advanced in programming, many times what happens is programmers will read everything as a string or a char array and then check. Like say they might read in, say input your average, whatever, your average, your age, whatever. So that average, they're gonna read as a string up until that space. So once they read that in, then they'll take it and they'll say, okay, does it have numbers? Okay, does it have a decimal place? Okay, so now we're gonna take it and we're gonna convert that input into a fraction, or not a fraction, a double. You understand? So it's kind of it's validating it before using it. All right. So that's what normally happens. All right. But like I said, you got to make sure when you read multiple values that it stays in line with what? The data type that you're trying to receive, okay? For those variables that you input. Got to make sure of that, all right? Now, then like I said, the multiplication expressions which you already had for your assignment, we have to know how to express or write an expression out. You got to. In computer science, we're gonna have to. And I think that's most of the reason why we learn the math, you know, how expressions work, or how you computate certain formulas and whatnot. So you're not afraid. So you have that ability to say, okay, I could take this and I could do this with it, and I can turn it into an expression in C++. All right. So looking at this, R equal X. Okay, just taking X and storing it into R. R equal 4, same thing. Taking a constant and storing it into results equal 4, result. Then here, result is equal to 5 divided by 3. Now let me ask you this, and we talked about this. If results were, the variable was double, and we did 15 divided by 3, what would be stored in result? Okay, I'm gonna ask you, would it be 5.0 or 5?
5.0.
When we talked about promotion and demotion, it would be just 5. The reason being, this is int, this is int. So it's gonna say I'm gonna take this and it's an int and store it in there. You got what I'm saying? So it's gonna only output the 5. You got me? Now, again, if there was 10 divided by 3, which give us what? 3.333333, whatever, right? What will be stored in results? Huh? 3, only 3. It's gonna throw away the what? The decimal place, because int divided by int gonna give us a what? A int. So it's gonna store that 3 in a double. Now, but if I do 15 or 10 divided by 3.0, what happens?
It'll be 5.
No, 10 divided by 3.0. What will be stored in result? 3.33, because what? The expression was promoted to what? A fraction, right? Because we have the 0.0 in there, right? An int, a float, and it promotes it. So now it stores, and now when I output it, if it's double, it'll output that point, whatever. Okay? Remember we went over that? Give you an example. Let's review it. All right? If we go here and we go to online GDB, all right? If I can pull it up. Okay, we go to online GDB. I'll close this out. Go to C++, and we do something like found include. How many people do this before they write their program? This will help.
We gave us the best of time.
This will help you, because all you're worrying about now is your logic. All right? You're not worrying about I missed the closing parenthesis or curly braces or something. So here, if I said int x is equal to 10, all right? All right? And I'll just say int y is equal to 3. And I'll say double total, all right? And I'll say total is equal to x divided by y, all right? And then see out total. All right, so now, when we run this, what our answer should be here? 3, right? So when we run it, we should get just 3. All right? We got 3. Because what? An int divided by int is going to store what? It's going to take that to 3 and carry it over. Even though it's double, there's no decimal place associated with it because it's a whole number sent over. All right? But it's still double. But if I do this, I'll change this to double. Now what our answer gonna be? Correct. Because now we're gonna promote this side to double, and this side is double, and it's gonna give us our result as a what? A double. So when I run it, you understand? So same program, all I did was change the data type so that it can give me what? My decimal place. Yes, sir, Mr.
Tabor.
Tabor.
I found something wrong with the test.
What's that?
X equals 18.0 divided by 4 is 2. Is 4.
I'd have to look at the actual the code.
I just ran the code right now and it's giving me 4, which is what I answered, but it told me the correct answer was 2.
Okay, like I said, I'm gonna look at the code to see what was prior to that, and whatnot. All right, so you can leave it up. All right. So now, okay. So looking at this, we get 3.3333. So it was promoted. So that's how, like I say, you would get your decimal value. Because what? Like I said before, if you had a construction company or whatnot, and you was dealing with gravel and concrete and whatever, those points or point whatevers really do matter, correct? And you can be a job short or whatever by not having those fractional values. All right, so you got to be very, 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 very careful. All right, so let's get back to the notes. Okay, so look at these notes. Let's see. Like I say, the numerator, denominator, all this did was take what? Everything was double, so it's what? Everything's double, so the value it stores in it, where's the output? Here, and outputting it as double because what? We don't have it assigning it to a value, we saying output that expression. Remember I told you, we don't normally teach you how to program that way because many times you get a value, you may want to hold it and use it for later purposes. So, but you can use Visual Studio somewhat like a calculator, all right? I can do this. I don't have to do double whatever, all right? I could do this, double this, or either one of them. It could have been just one of them. Double this, and I could take this out, and then I could say see out, rather than say see out total, I'll just see out what? The expression, all right? Okay, so what I could do, I could just tell it to see out the expression, which is pretty much the same thing, right? If I'm saying total is equal to x divided by y here, right? And print out total, and I'm saying, okay, output x divided by y, I should have what? The same answer, right? But sometimes as programmers, when I get this total, later on in my program, I want to use that total to do something. So what may happen is, rather than using total, you might try to rewrite that formula, and it could be a long formula, and you miss a variable, or you change the sign in it, and all of a sudden now you're trying to get the same results, but you done rewrote the expression wrong. All right, so that's some of the reasons why we try not to teach it to you that way. But is it right? Is it wrong? Programmer preference. All right, programmer preference. All right, so we run it, and here we go. See, we get the same answer, right? Because we just outputting what the expression results.
If you don't put it like x divided by y in the parentheses, it just prints out x divided by y.
Well, no, it still will do it, but all we're doing is grouping it. It should print it because it's an expression. It should still work, all right? It should still work because it sees it as an expression, all right? And then too, it may depend on certain compilers. Certain compilers may want to see it grouped before it solves it. It just depends, all right? All right. So like I said, it's still gonna work because it look at it as x divided by y, okay? Because if we don't have to do it here, right? We didn't have to do it here. All right? All right. Now, so order of precedence. We talked about that. What and subtraction? What's the next precedent for above and subtraction? Let's see if we know those operators. Multiplication. We talking about just the operator.
No, division and modulus.
Multiplication, division, and modulus. Right, class? They have a higher precedence than adding and subtraction, right? And we know how to add, what adding is, we know what dividing is. But what is modulus? What does it do?
The leftover.
It returns the remainder or the leftover, correct. Everybody got that? The modulus returns the remainder. So, what's one modulus 2? Huh?
0.
What?
0.
0.
Oh.
There's no remainder. Because 2 going to 1 is point whatever, so there's no remainder, right? But 2 modulus 1, right. 1 goes into 2. 2 times 0.
Still 0.
Right, because 1 goes into 2, how many times? 2 times 0 remainder, right? Alright, but like say 3 modulus 2 would be 1, right? Alright, now here are some expressions, and we know what, then we talked about this too, you multiply before you add. Here you would divide before you subtract. Here you would divide before you subtract. Here you would multiply here, then from left to right you add and then subtract. Here you would do the modulus and then you add and then subtract. Here you would multiply, then subtract, add and subtract. I mean subtract, add, subtract. Alright, but then like Miss what in the back? Ephraim said, there are situations where we have grouping, right? And that takes precedence over your signs also, because you always have to work what? From within the parentheses outward, right? So even if I have an expression where I'm adding here, and this is multiplication, I still have to solve from within the what? The parentheses first, and then work my way out, all right? So same thing with each one of these. Solve here and then divide. All right, solve here and then multiply and then add. Solve here, and then modulus 2 and then subtract 1. All right, solve here, then multiply and then divide. Okay? Any questions? Anybody with any questions? All right. All right. So now it tells us here examples how we actually convert to an expression in C++. And I gave that to y'all before we did the assignment. 6b, 6 times b. 3 parentheses 12, 3 times 12. Then look, 4xy. Remember I had 4ab, 4 times x times y. All right? So you're multiplying x times y times the 4. All right? Then here are some expressions with fractions in it. So here what they did, they said, okay, y is equal to 3 and x over 2. So what they did was the x over 2 times the 3. So you're really multiplying x over 2 times 3. All right? So here, 3 times x over 2. Here, 3ab plus 4. 3 times a times, or 3 times, I'm saying a, b times c plus 4. And then here we got a numerator, right, with an expression, a denominator with an expression. So we must what? We must solve for the numerator. So if we're going to do that, we need to group it, right? And then if we solve for the denominator, we have to group it. Because look, our divide is here, and look, everything in the numerator we solve, everything in the denominator we solve, and then we divide into it. Okay? All right? Everybody got that? Now, the power function. Power function is just a math function that allows you to raise a number to a certain power. Okay? There's many different math functions. All right? Tangent, cotangent, sine, all those functions. There's also square root. If I go here, not here, if I go to online GDB, I'd have to do the pound include math.h, and then now I can take this number here, all right? I have these two numbers, so I'll take this off, all right? Take this off, and I can say total is equal to POW x comma y. So what am I telling you here? 10 to the third power, which is 3 zeros, 1,000, right? All right, so when we run it, all right, why? What we did here, even though we calculated total here, I'm outputting x divided by y still. So I want to output what here? Total. All right? Because our expression actually changed, correct? Now I could have put power, whatever there and still got whatever, right? So see what happens? That's how you use the power function, all right? Now, if I do this, I think I can I can say, I'll say double P total is equal to SQRT, and I'll put 10, square root of 10. I think that's the formula. All right, and what I'll do this. What I had, P total. All right, so I think that's the square root formula. We'll see, but I think it is. See, so look what happened. I can use that particular command in my program because I loaded what header file? Math.h. You see what I'm saying? So there's many different math functions that I can use when I add that library to my program. Okay? All right? So I could do all those different things. And like I said, you could create your expression. So what? When I created an expression, if I did the square root of 4ab minus whatever, I'd have to do what? Square root, and then in parentheses, whatever. 4 times a times b minus whatever, right? Close parentheses. And it should give me the result square rooted, right? Correct? So those are some of the math functions, all right? Okay. All right, so all that does is tells you how to do the square, all right? And I showed you how the square root. And like I said, you need to go over these examples so that you can understand what is going on. All right, we looked at this long, double, float, unsigned long, and all what happens is, if I have unsigned long, I have a larger range of values that I can use. Because what? It takes away that what? The signed position, and now my number can be of a larger byte size. Okay? That can be stored in the computer. Alright? But it tells us these are the data type rankings. Alright? The int is the lowest, and then you got unsigned int, long, unsigned long, float, double, and then long double. Remember, when we had a number and we divided it by a float, it promotes it, right? If we divide it by a double, it promotes it. You got what I'm saying? So that's what it pretty much is talking about, promoting and demoting values that you actually run in an expression. All right? All right. Assume that year is in and interest rate is float. It will what? Promote to what? It will promote to what?
Float.
Float. Because float has what? Remember that higher precedence than in. Alright? So that's what it's talking about. That return value will be promoted to a float value. Alright? Alright. Alright. Talking about integer division. We looked at that already. If I divide this int by int, regardless if this double, I'm gonna get a what value? A whole number value, right? And I can lose out on a lot of what? Decimal values that may be needed if I'm adding a lot of decimals and whatnot to something or whatever. But once I do this, it promotes what? 15.0 divided by 6 is gonna promote it to get the double on the float, and then it what? It's gonna store it into the double here. Alright? And it's gonna give me the decimal place. Alright? Alright. Overflow and underflow. We talked about this earlier, because remember I asked you if we had a variable of short. Remember the short value? The lowest value for short was a negative 32,000 and something. Right? That can be stored in that variable of a short. The highest value was 32,767. If I add 1 to that short value, what would be the answer? If this was declared as being short, all right, this number here, and I added 1 to it, what would be the value?
It would be a negative.
it would revert back to the beginning of the value list and start there as 1, 2, whatever. So it'll be at that first position, which would be negative 32,768. All right, and some of you might say, "Well, Mr. Master, I don't believe you." Okay, let's take it. Let's do that. Let's say we change this to short. And what was that value? 32,767. 67. All right. So I'm gonna show you something here. It's just a shortcut. I'll say X plus plus. What I'm doing here, I'm just adding 1 to X. All right. That's all that does. Add 1 to X. Anybody understand? X plus plus is just saying X is equal to X plus 1. So we're just adding 1, which in our minds, should be what? What should be the output?
32,768.
Correct, to us, right? Because we don't deal in short, long, and all this, right? We just deal in the number. But when we look at this, we got X, and now let's print out X, all right? We'll say we'll print out X, all right? And I'll change this to X, and did I do anything with total X or Y? That's too large. We'll just take this off. All right, take this off. And we'll take this off. All right. I thought I commented this off. Why not comment? Should be commented. Let's run and see if it is
It's in the
commented.
quotations.
Oh, no. It doesn't matter though. Oh yeah, because I included it here. Yeah, this is the problem. Here. No, it's all. All right, so let's run it. You understand? See what happened? So it went back to the negative side. It didn't increment to like a positive number. It went back into that range and started back from the very beginning, and it increased. Even if I did add it for plus 10 equals X plus plus 10. Same thing. We run it, and now we're gonna go to the negative side and move up 10 from the negative side. See? So it just moved up from the 48, whatever, to 10 times, still going back to the maximum range side. All right? So you got to be aware of the data types that you use and the range in which values are stored into it. All right? Because you can't run into issues that way. All right? So make sure you watch that. Typecasting. Now, remember, typecasting is something that's good. You can take, say, like, remember I told you a lot of times when you get advanced and you're reading in data, to validate it, you read it in as character, right? So you can read in something as character and then do a typecast to say, oh, I want it to be used as this, right? So look at this. So here we have this double this number, right? I mean, which is num, and it's 3.7, correct? Now, remember your programs you did when you did the feet conversion, right? You could have used typecast, right? Because what you could have done was took whatever number you divide by, you typecast it, and just get the what? The whole number, all right? Or if I told you all these are strings, all right, or string data, you take it, typecast it, and do whatever you have to do to it. And in the memory, it's all character, but you done grabbed it, change it to use it like you want, and everything in the system is character data. All right. So what they did here, number is 3.7, but then it says okay, int val. So now, what they're trying to do here, they don't want the remainder. It's time. Thought we were gonna look at that.
I left the oven on.
Huh?
I left the oven on.
Alright. Oh, all right. Oh, we just left the oven. Alright. So now, if I typecast a number as int, I'm telling it that what? Number gonna change to what? Not actually change, but the value I'm trying to pull from it is what? Huh? If I'm typecasting as int, what number I'm pulling from it? Which is 3. You understand? So I had a number that was 3.7. I typecast it into an int, and I'm taking it and storing it in the val. So what's val gonna equal to? Huh? 3. All right? Everybody understand that? But what they did, rather than say val is equal to number, they did a typecast to say take that and convert it, and then to int, and then whatever left, put that, whatever it is, put it in val. Okay? They just did a typecast. All right? But you could do it with a string. You understand? If you had num, which would say string, num is equal to double quote string 3.7, you could typecast it to be int. You understand? And now it takes that and use that as an integer value. All right? So look at this. Look what happens here. They're trying to find the average number of books that a person read per month. All right? But what they did, int books, int month, double per month. But looking all through this, they typed in the number of books they read. They typed in how many months it took them to read it. But then here, they did a typecast on books. All right? So static cast double book. All right? So what they did right here, they just allowed the expression to be what? To be what? Promoted, correct. You understand? Because what? Books is in and month is in, right? So right here, rather than trying to create a variable and multiply by point, whatever, you just typecast, divide, and what? It's promoted, and it's going to take the value and send it as a double. You got what I'm saying? So everybody understand what happened? They used the typecast to promote the value that they got to store it into the variable per month so that they could get 4 point whatever. Because what? I still divided by an int and an int, but the typecast says, okay, use it as a double. Use books as a double. Right? Now, is books changed in the system? No. It just did a typecast at that point. Everybody understand? It didn't change the value of books or anything. It just said, okay, take whatever books is, now use it as a double, and when it used it as a double, it promoted the expression and it stored the value as a double value. All right? So everybody see how the purpose of that typecast, how you can use it. All right? But it says warning, the following statement will still have resulted in integer division. All right? It says per month is equal to static cast book divided by month. It said the result of the expression book divided by month is 4. When 4 is converted, it is a double. All right? It's converted to the double prior to the division operation. All right? This forces C++ to automatically convert the value of the other operand to a double. All right? So here, look at this. Now we talked about numbers. Letters really are stored as numbers, right? So what happens is we said what? Int number is equal to 65, but it's an integer, right? But then when we output it number, which is what? An integer, and which is the value 65, right? But look what they did here. Static cast char number. So now you take a number and says, I want to represent it in what? As a what?
There.
As a character. So now it has to go to that ASCII table and look for what? 65, and says, okay, what's the character value for 65? The letter A. Right? What's that? What's wrong, Mr.?
Oh, no.
What you want to say?
Oh, no.
Oh, all right, but you understand what's happening, right? You understand what's happening. But remember, in the first in the first course, we tried to get you away. We didn't want to introduce that to you because we didn't want you to get confused with letters being numbers or whatever, right? Stick with integer data, stick with character data. But now you see that what? Character data is actually numbers, right? And you can take a character and print its integer value. Right? Yeah, Mr. Something. I thought you had a question. Look like you got a question.
So basically, static cast is just a shortcut, so that way you don't gotta go up and add more.
Variables, right, that's
to your
right.
actual program.
Right, because what happens when you add variables to your program? You're creating a larger stack, because the compiler and the operating system has to keep track of all these variables and whatnot, which takes up computer's time, computer speed and whatnot and all that, right? So the less variables you have, like I said, if you got a large program, less variables, man, the faster it's gonna run. You know what I'm saying? Because you just use it a little bit that you got, take it, convert it, whatever, and whatnot. Right. All right? All right. So that's static cast. All right? Multiple assignment statement. Look at this statement here. A equal B equal C equal D equal 12. What that statement is actually doing?
Is assigning 12 to all of them?
Correct. Starting from the right, D is equal to 12. Okay? Then C is equal to D, which is equal to 12. Then B is equal to C, which is equal to 12. Then A is equal to B, which is equal to 12. So you see how the 12 just came on down. It didn't go from left to right. You had to start from the back, coming back to it. Right? So A equal B equal C equal D. We don't know what they are yet. Equals 12. Now we know that everything equals 12. All right? So that's just a way of assigning multiple variables to same value. All right? Here, looking at this. Now, this is somewhat, it's not exactly what I showed you. But here, look at this statement here. And it says combine assignment operators. Here, number equal number plus 1. What are we actually doing the number? Increasing it by what? By 1, right? When number is on both sides of the equal sign, we are not actually just overwriting it with a new number. We incrementing the right side by its value plus whatever we're doing with the expression. And it could be minus or whatever, right? But here, in this case, we add. It could be multiplication, it could be division, it could be modulus, could be whatever, right? Whatever that expression is, we taking the value on that left side and using it on the right to give us the value, right? So we're not just saying number is equal to X, okay? Whatever X is, overwrite that. No, we saying number is equal to number, then we got plus. Right? So number, whatever number is currently equal to, we taking that value and using it on the opposite side. Now, this is a problem that you're gonna have, you're gonna run into, and I'm telling you're gonna run into it, and like I say, you need to pay attention now. When I use a variable on both sides of the equal sign, it has to have a value. Give an example. I can say int x equals 5 or y equals 3 total. All right? Right, class? Now I can say total is equal to total plus x plus y. Then see out program run?
No,
Huh?
no.
Why not?
Because total doesn't have a value.
Total is unknown. We do not know what total is on both sides of the equal sign. See here? So when I say total is equal to total plus x plus y, my expressions read what? Unknown plus 5 plus 3. And what that's equal to? Can't be solved. Right? Right, class? And I'll execute it. Back in the day, and it was years ago, the 80s, whatever, when compiler was developed, when you created a variable, and it was integer or a number, it automatically assigned it 0. But as compilers have grown and become more and more robust or whatever, and like I guess to protect, things from going on happening within a code, now you must give it a value. Whether you're giving it 0, you as a programmer will say it is equal to 0. You understand? It's not gonna the computer not gonna just say, oh, I'm gonna give it the value 0. You as the programmer have to. So when I run this, watch what happens. Oh no, it's gonna run on this. I forgot. No, okay, it didn't. Right. Wait, why is not declared? Yeah, X, Y, total. I understand total. Not, oh, I see what I'm saying. I see here. I put a semicolon, comma. Let's run it. So, watch what it's saying. See, that's this compiler. This compiler is going to work. Let me take it. And now I need to go to this other compiler. Visual.
Compiler recognizes.
It will, yeah, it will. It's like it's got some of the older, and it might not be as robust as the Visual Studio, So that probably why. It's just an online compiler, whatever. But you saw that it did work, right? It worked, and let's create
So
a.
for homework purposes or something, if we did that.
I want you to initialize, because you're gonna run into issues when you start dealing with other applications and whatnot. So I want you to start and understand that if I introduce a variable and I'm using it on both sides of the equation before I initialize it to a value. Because you're gonna, like I said, you're gonna start programming and gonna run into these issues like, I don't know what's wrong. And then somebody will say, you need to give it a value, initialize it, give it a value. And you say, well, I never had to do that,
Basically, just for safe practice, always initialize.
Right, if you're going, right. If you know it's 0, put it at 0. Right. So now, let me open up a Visual Studio assignment. Yeah, see, this take up a lot of resources. I'll say. All right. So see how much clicking and whatever it takes for Visual Studio. But like I said, it's a good application. It just take up a lot of resources of your computer. All right. So now, then I have to right click, add new item. C++, CPP, blank file, and I can paste. All right, so see I have this program, right? Exact same program, I just copied and pasted, correct? So when I try to build it, okay, Control F7. See? Uninitialized local variable total, meaning it's there, but I don't know what it is. It don't have a value, but I'm using it on the expression side of my program, and it's undefined. Everybody understand that? I got total here. What's total? We don't know, correct? Then I say total equals total. What is total? We don't know. So how can a compiler give us an answer if we don't know what total is? You got me? So The other compiler is a more generic compiler, and it says, okay, I'll just set it to 0, and it's gonna work. But this is a more, comprehensive compiler to where, I'm not gonna do that. I'm not gonna just take for granted that it is 0. The programmer will have to say equals 0. You understand? And when I run it now, or if I compile it now, now it's gonna say succeeded. And now when I run it, when I do the control F5, I'll get the exact same results I got from the other one. I set it to 0, get the same thing. You understand? Got the exact same answer. But I had to what? If I'm using it on the right side of the expression, I have to give it a value, because the computer will not just try to determine, oh, it's 0, right? Everybody got that? All right. So now, this is my point. When you write code, you might say, okay, well, I'm gonna do it this way because it works on this one. That's okay for that moment. But hopefully you wanna write code that'll run where? On all platforms. You understand? So when you do that, then you're not gonna fall in a pitfall later on. You start developing software for a company, and it's like, oh yeah, but it worked. I got it, man. It's everything perfect or whatever. Go to their system, and their system, oh, error. And you're like, man, wow, well, why is this? And it's because what? Well, I ain't wanted to do that. It worked on this one, so I ain't worried about that. No, try to get it to where it'll work on all platforms, and that way you're learning and growing, all together, and you ain't got to keep going back and forth, remembering what you didn't do, what you let get by, or whatever. All right? So, like I say, make sure that it's on both sides of the equal sign. All right? So, here, this is x equals x plus 4. So we have to know what x is to solve it. Same thing here. Need to know what x is to solve it. Need to know what x is to solve it. Need to know what x is to solve it. And see what this says? Assume x is equal to 6. So in these examples, we have a what? A value for x. Right? We have a value for x. Alright? Now, look at this. This is something I want you to understand, and I'm going to try to put out a quiz for you to do this. These operators here, plus equal says, whatever I have on the left side, I want to add it to the right side to solve it. So, here, if I had 5 here and say x was 3, this is just like saying 3 is equal to 3 plus 5. You got me? Whatever I have on the left, I'm adding it to the right. I'm adding it to the expression. Here, minus. Whatever I have on the left, I'm adding it to the right. Whatever I have on the left, I'm multiplying it by the expression on the right. Whatever I have on the left here, I'm dividing it by, I'm gonna be divided by the expression on the right. Whatever I have in this variable here, I'm gonna get the modulus of that. Take that and get the modulus with that expression. All right. So look here. This is the shortcut of writing it. Which one is right and which one is wrong? Use a preference. A programmer's style. Doesn't matter. But some like to use this. X is equal to.
What's the other one?
All right. X plus equal. X equal x plus 5. A divided equals B. X equal A divided by B. All right. C modulus equal 3. C is equal to C modulus 3. And if it was an expression here, like if this was 5 times 2 minus y, this would be x is equal to x plus 5 times 2 minus y. You understand? So you just take it and use it on the other side. All right? This is the end of the class. So what I'm gonna do, class, I'm gonna put some examples out there for you to solve. All right, in a quiz, and then when we come back on next class period, we're gonna start dealing with format now output. In format now output, we're gonna need to know how to use. We're gonna need to load one header file, which is man IP, alright? Which we can shift our decimal places and whatnot and all this, alright? And then deal with significant digits. Alright, class, so I'll see you on next class period, alright?
It's not
Upload what? It's too late. You just did it.
No.
Did it while I was in class.
No, I couldn't figure out how to screenshot.
Didn't I tell you in 10 minutes?
Can you please?
I didn't know how to screenshot, so I had to look it up.
I found the right account, it was already live.
The right account. You got more than one?
Well, because I had pressed login before, so when